Okay, in this video we'll be looking at the normal curve and percentile ranking. On the front page I'm going to go through the derivation of the normal curve percentages, but once we do these percentages, they are the same for every single problem. So on your formula sheet, you are given this information about this. Is referred to as the 68, 95, 99.7 rule. So these percentages are given to you to help you derive it if you don't want to memorize it. But I think that once you do a few problems, you'll once you memorize one side, it's symmetric, so the sides just mirror one another. All right, so in a normal distribution, approximately 68% of your data, my pen here, approximately 68% of my data falls within one standard deviation above and below the mean. The mean is always here in the center, and then standard deviations above the mean are to the right, so we would refer to this as 1 standard deviation, 2, 3 standard deviations. These symbols that I'm writing here is standard deviation. It's Greek letter sigma. It's like a circle with a tail on top, and then this would be 1, 2, 3 standard deviations below the mean. And what that first sentence there is saying is that 68% of my data is between 1 standard deviation above and below the mean. So remember, we're symmetric, so that means then 68 divided by 2, 34% of my data is from 1 standard deviation below the mean to the mean, and 34% of my data is from the mean to 1 standard deviation above that mean. Okay. Your next data point says that there is 95% of your data is between 2 standard deviations above and below the mean. So now we are referring to that from here to here represents 95% of our data. So in order to calculate that, what percentages go in these next two rectangles, what needs to happen is I need to take out the 68% that's already been accounted for. So I would do 95 minus 68, and that would give you 27. Now you've got 27% that needs to be divided up into these two rectangles, so take 27 divided by 2, and that tells you 13.5% of your data lies in the next two rectangles. 13.5%. All right, then we'll move to our next piece. 99.7. Go back up here. Try to change my color. 99.7% of your data falls within 3 standard deviations above and below the mean. So now we're saying that from here to here represents 99.7% of your data. So to figure out now what goes in these next two rectangles, I'm going to do 99.7 minus the sum of all of these existing 4 rectangles, which we know is 95%. So 99.7 minus 95 puts you at 4.7. So you've got 4.7% now that will be divided by 2, and that puts you at 2.35. So 2.35% of your data is between here and here. So virtually, almost all of your data falls between 3 standard deviations above and 3 standard deviations below. And when we say virtually all, it was 99.7% of your data. So that means there's a minuscule amount that it lies above 3 standard deviations and below 3 standard deviations. So in order to figure out what that amount is, figure out what goes in those little tails there, we just do this, and we know that the full normal curve represents 100% of your data. So you're going to take 100 minus that 99.7, and that's going to put you at 0.3. Then you're going to take that 0.3 and divide it by 2. That's going to put 0.15% in each of these last little rectangles. So a minuscule amount is left over in these last two rectangles here. Again, once you've done a normal curve, these percentages that I just derived for you here are always the exact same. So again, if you memorize one side, you know the other side. Okay? So what I'm going to do is I'm going to flip it over, and I'm going to do example 1 with you, and then that way you can try example 2 on your own. So if we flip it over, Here in example 1, it tells us that on the math part of the SAT, the scores are normally distributed with a mean score of 500 and a standard deviation of 100. They want us to fill in and label this normal curve and then answer our questions. So they tell us that it has a mean score of 500, so we'll put 500 here in the mean. A standard deviation is 100, so that means on the right hand side I'm adding 100 to this 500, so 500 plus 100, that puts me at a score of 600. Add another 100, add another 100. On the left-hand side of that mean, I'm subtracting 100, so that would put me at 400, 300, 200. And we'll just label this as your SAT math score. And I'm going to go ahead and put in our percentages. Remember, we know that there's 34% here and here, 13.5 in the next two rectangles, 2.35 in the next two. Always percentages there. And then that minuscule amount, 0.15% of the people are making above 800 on their SAT or below 200. 0.15%. Okay, so now we're ready to answer our questions. And the questions below say, in part A, what percent of the SAT scores are above 400? So here's your 400 mark. And you want to be above that, so you want to take every percentage that you see and add those values. So if you add all of those values together, you should arrive at 84%. What percent of, in part B, what percent of the SAT scores are above 500? So 500 here is right in the center. And so you're taking everything there to the right and adding them together. Now, anytime you're in reference to the mean, you can check behind me, you should always be 50% above and 50% below. So you could add those 4 rectangles there and you should arrive at 50%. Also, like whenever you do your test, if you ever forget these percentages or for whatever reason you can't remember how to derive them, at least a loose check for yourself is make sure that this under here adds up to 100, because if it doesn't, then you know that's another red flag that you've done something wrong. Part C, what percent of your SAT scores are below 700? So here's your 700 mark. You want to be below, so since you're below, this time you're taking from here and adding all the way over. You know, a quick way in terms of adding, you know that from here to the central part, the center, the median here, is 50%. So then you can take your 50% and just add those two to it. That would be a little shortcut there. That should arrive you, though, at 97.5%. Part D is asking just a little bit different. It's asking for probability. You'll first still find the percentage, and then after that you will convert and find probability. I'm going to erase some of these marks up here so that I won't get anything confused. And move then into my probability. So in Part D, it's asking for the probability that they will score between 300 and 700. So here's my 300, and here's my 700. I would need to add from here to here to get my percentage. So when you add from there to there to get your percentage, you should arrive at 95%. Now to change that to probability, all that you do is just divide by 100. And so that means, okay, it's 0.95. Probability in this case will be answered as a decimal, okay? Moving forward, we would answer it more as a fraction, but in this section we just answer it as a decimal for probability. In Part E, it says approximately 99.7% of the SAT scores lie between what two values. So always start in your mean, and you know that from here to here is 68%. From here to here we know is 95%. So once we add these two, that's how we land at our 99.7%. So that would be then between 200 and 800. Between 200 and 800 points. Okay. Letter F wants to know what score do the upper 16% of the students get on the math part of the SAT. So I'll erase again. I've got a lot of marks here so that we can keep it all straight. Upper 16%, so when you say the upper 16%, you're talking about the right-hand side. So what needs to happen is you need to start here on the far right and take these rectangles and start adding until you arrive at the percentage that you're given. So I'm arriving at 16%. So I would have to add all the way up to here. And so that means that that would be a score of 600 or higher. You can't do 600 to 800. If you just say 600 to 800, you're not talking about the full 16%. You've got to include those few people that are beyond scoring an 800. So you would say 600 and higher. Okay. And letter G, what score do the middle 68% of the students receive on the SAT? Always start in the middle, go one standard deviation above and below until you arrive at your percentage. I want to go 68%, so I just need to go one above and one below. And then that puts me between 400 and 600. So between 400 and 600. And then lastly, in part H, what score do the lower 2.5% of the students get on the SAT? So here's your 2 point, so since they say lower, start from the bottom here and add until you get to this percentage. So I would add until I get right there. So that would be a score of 300 or less. 300 or less. Again, you can't say 200 to 300 because that's only 2.35%. I want a full 2.5%. So 300 on a score of 300 or less. All right, good opportunity for you here would be to stop the video, try example 2, make sure that you're tracking with all of those answers, and check yourself by the solution key. All right, I'm going to flip it on over then to the last page, and on this page we're looking at our last definition for this section, which will be percentile ranking. It's another way to analyze your data. And with the percentile ranking, it's basically just giving you a comparison or ranking for a given value or given data point within a data set. A lot of times your places where you've seen percentile rankings may be if you've ever taken a standardized test or your child has taken a standardized test, or if you have a child, and if you remember whenever you take them to the doctor whenever they're after they're first born, they give them percentile rankings for their height, their weight, their head circumference, and there may be other values, but those I can remember. Anyway, what those percentile rankings are telling you, for example, if it's in a class, if you were at the 95th percentile in your class, then that means 95% of the students are at your level or below you, and only 100 minus 95, 5% of the class is above you. In terms of going to the doctor and your child's percentile ranking, let's say that you went to the doctor and that they were at the 60th percentile for height. Then that means 60% of kids your child's age would be at their height or shorter. And then 100 minus 60, 40% of the kids at your child's same age are taller than your child. Okay, so always percentile ranking is always your percentile ranking is always the number of data points that lie below or the same value as you. 100 minus your n gives you the number of people that are above you. Keynote here to find percentile ranking, your data has to be in order, so always be sure that you do that. Percentile ranking, that formula is on the formula sheet for you, and it is simply just counting. It's so you just count the number of scores lower or equal to your particular data score divided by the total number of scores in the sample or the population times 100. So essentially it's like a part over whole times 100. So here in example 3, I've given you an example of students' grades that they got on their latest history exam, and I'm telling you, I want you to find Julie's percentile ranking if she scored an 88 in her class. So hopefully you can recognize here this data is definitely not in order. So the first thing I would need to do is put it in order. So what I like to do, if I can, is put the data right underneath it, so then I can make sure that I don't miss a data point. So 45 is the smallest, and you can always cross them off too. Then it goes to 58, cross it off, 68, 72, 87, 72, 87, 88, a couple of 88s, 88, 88, 89, 92, 95, and 100. 100. All right. Now, we know that Julie scored an 88. We don't know which one of these 88s is her, but it doesn't matter. Remember, your formula up here tells you it's the number of scores lower or equal to your data score. So any one of these 88s gets included. So I'm counting from here to here. There's 1, 2, 3, 4, 5, 6, 7, 8 students out of a total of 8. So this is 8, 9, 10, 11, 12 students in the class times 100. So you're just putting that in your calculator. 8 divided by 12 times 100. You get 66.66667, so 66.67. So we're just going to round that up to the 67th percentile. So that puts her at the 67th percentile in her class on that history exam. So what that means then is that Julie scored at or better than 67% of her class, while what percent scored better than her? 100 minus 67, 33% of the class scored better than her. Okay. Example 4 is back to the celebrity income data from the previous set of notes. So this would be a good one then for you to try. Put that data in order and find the percentile ranking of, I'm asking for Beyonce. Okay, so you would find the percentile ranking of her income of 81 million. Okay, answer key is provided for you online in Blackboard. And then I'll do one more down here with you. Let's say we're doing example 5 here together. It says, if a baby is born at a height that puts him at the 57th percentile, what percent of the babies would be taller than him at the same age? So since you're asking what percent would be taller than him, more than him, you can't just answer with 57%. Remember, 57% would be at his height or shorter. 100 minus 57 would tell us what percent are taller than him. So 100 minus 57 would land you at 43% then of kids would be taller than that child at the same age. Okay, and then I encourage you to try example 6. All right, hope this helps.